Surface area of cylinders and prisms. We're not adding anything incredibly new today, but mostly when we've worked with surface areas so far, we've been working with cubes and rectangular prisms. Um, and cubes and rectangular prisms, their surface area are just made up of squares and rectangles. It's really easy to kind of add up all their areas. But cylinders and prisms that aren't rectangular prisms, we probably really want to start concentrating on this formula. And we've seen it before, but we need to get better at it. B in this formula is the area of the base, and surface area consists of two bases. Any prism, any cylinder has got two congruent polygons or circles on the top and bottom of it, and those are called the bases. So we always multiply by 2. And then the P is the perimeter of the base. And the H is the height of the prism. So the distance between the two bases, the distance between those two congruent polygons or circles on the top and bottom of the prism or cylinder. And then the pH, we have a special name for that. P times H is what's known as the lateral surface area. The lateral surface area. So like the walls of a room are the lateral surface area because you're not including the ceiling and the floor. Lateral surface area. All right, so we're going to find the total surface area of these figures. Specifically for A, we're looking at a cylinder. Okay, a couple things we got to do here. To find surface area, the first thing we got to do is find the area of the base. Now the base is a circle here, so we're going to do pi r squared. It says right here we're going to use 3.14 for pi. And the radius is 5 because I know the diameter is 10. So we'll do 3.14 times 25, which is, a calculator work, 78.5. Now the next thing we need to do is find the perimeter of the base. Well, perimeter of a circle we actually call circumference. So we'll do pi times d, or 3.14 times 10. No calculator necessary there. It's 31.4. So now we've got everything we need to be able to figure out the surface area of this cylinder, 2b plus pH. Well, the area of the base is 78.5. The perimeter of the base, or circumference, is 31.4. And the height of the prism is 6. The distance between the two circles is 6. So we get, we multiply 157, and we multiply again, we get 62.8. Then we'll add up those two values, and we get the surface area of the cylinder, 219.8 centimeters squared. Okay. So the formula is not very complicated, but you actually have to find the area so you can plug it in, and find the circumference so you can plug that in. Just this goes right there, and this goes right there. This goes right there. All right, next up, we got a triangular prism. Same process occurs. If we're going to find the surface area of this, we got to find the area of its base. Its base is a triangle. How do you find the area of a triangle? You do 1/2 base times height. The base is 6. The height of that triangle is 8. We're kind of ignoring the prism, just looking at the base. So that's half of 48, which is 24. Now the perimeter of the base, the perimeter of the triangle, is 6 plus 8 plus 10. 6, 8, 10. 6, 8, 10. Right there in green. It's 24 also. Well, it's 24 inches as opposed to 24 square inches. So now we can figure out the surface area of the prism. We'll do 2 times the area of the base, 24, plus the perimeter of the base, 24, plus the height of the prism, 10. 2 bases makes 48. The lateral surface area is 240. So the total surface area is 288 square inches. One more time, real quick. Area of the triangle, the base goes right there. Perimeter of the base goes right there. Height of the prism goes right there. do another. No, actually, let's look at this a little closer. What is the lateral surface area of the cylinder in problem A? Let me go dual screen on this. Problem A. Sorry, bear with me here. The lateral surface area of the cylinder in A. Well, there it is right there. That's 62.8. Lateral surface area is 62.8. And what that represents is, and I'm going to draw a net of that cylinder. It's real easy to draw a net of a cylinder. It's just a rectangle with a circle on the top and a circle on the bottom. You know, if we wrapped, flip these two circles down, it would be the top and the bottom, and wrapped this rectangle around it. Imagine just unrolling a paper towel roll at the end. Oh no, maybe that's not a good example. A soup can, taking the top and bottom off and cutting down the middle of it. And the lateral surface area is that rectangle right there. So it's the sides, and it's 62.8. Now the next question is, what's the lateral surface area of the triangular prism in problem B? So, sorry, it's going to make you watch that again. But the triangular prism, it's right here. It's this 240. Okay, it's real easy. It's right there. The P times the H. That's the lateral surface area. So if you're good at showing your work, you've already got this answer done. So the lateral surface area is just 24 times 10, the perimeter times the height. So for this one, it's the lateral surface area is 240 square inches. And I'm going to draw a net of this one real quick too. We've got that triangular top with the triangular bottom, a rectangle joining them, and a rectangle on the top and a rectangle on the side there. That lateral surface area is those three rectangles, which together makes one rectangle. What's the length of this rectangle? 24. Okay. What's the height of this rectangle? 10. 24 times 10 is 240 square inches. Same thing here. What's the base of this rectangle? It's the circumference of the circle, which we figured out. And what's the height of this rectangle? It's the height of the prism, which is given to us. Okay, one more. Find the lateral surface area of a 30-foot high water tower with a 40-foot diameter. Okay, lateral surface area is just perimeter of the base times height of the prism. Now, perimeter of the base in this case is a circle. So it's circumference, 3.14 times 40, which comes out to 1,256. Plug that in perimeter. The height we can see is 30. Multiply those two numbers. We get the lateral surface area of the water towers, 37,680 square feet. So, you know, if we knew how much square footage a bucket of paint costs, or covers rather, then we'd know how many buckets of paint we need to buy to cover to paint this entire water tower. All right, that's all I got for you today. You know, geometry's not been our strong point. It seems to never really be for 8th graders. So the nice news is you can watch this as many times as you want until your heart's content. I'll see you tomorrow, and feel free to ask questions at that time. Good night.